It's an honor to be invited to give a talk at the Technology Day. And what I will do is that I'm going to talk on technology and innovation, helping in making big things possible. And it will be clear what I'm talking about. I'm only going to take two areas, but one can actually go on to look at many more things. There are बहुत बार ऐसा होता है कि लोग बोलते हैं कि ये काम तो नहीं हो सकता है. Cannot be done is very, very commonly talked about in all sectors of society. And I think what I believe is there is one reason that it should be done, then one should start sort of saying it can be done. And that is what I'm going to try to talk about. And I'll take very quickly one short example and one relatively long example. For example, we always sort of say we want India to be highly educated and talented. Is that possible? Is it possible in 10, 15 years? We all often talk about the poor state of education that the country is. Can we really make a difference? And I'll briefly talk about why something like this is possible. And only when we start talking about that it is possible, we can actually make it happen. Otherwise, we can beat ourselves and all throughout our life and just get nowhere. Similarly, I'm going to talk about, will power cuts be ever a thing of past? I think it's very doable. Something that I'm going to talk about, something I think is doable in 2 to 3 years' time. Not 10 years, not 20 years. And I'm going to specifically talk about that. One can actually talk about many other things. And in a different talk, probably we have even looked at many of these things. For example, we have a public health center, one public health center in every 3 villages of India. Can we really make it work? And can we make it functional and make it effective so that health can be provided to all the villages? Can our agriculture attain fast growth? Will water be responsible for future war? पानी की समस्या हमारे देश में बहुत बड़ी हो सकती है. क्या किया जा सकता है? और इसमें सब में मैं समझता हूँ साइंस एंड टेक्नोलॉजी कैन प्ले अ मेजर रोल. आज अगर हम इसको समझ सकें और इस डायरेक्शन में काम करना शुरू करें तो कोई कारण नहीं कि 5-10 साल में 10 साल में हम इसमें मेजर मार्क न कर सकें. कैन गवर्नमेंट्स बी अकाउंटेबल? हम लोग सब त्रस्त हैं थोड़ा बहुत. क्या हम उनको कर सकते हैं? Can we leverage technology and innovation to fix large problems? And this is what I'm going to talk about. And specifically, I'm only going to talk about 2 of the sectors. First is education. Can India educate its youngsters well? हमारे यहाँ हमें हमेशा कहते हैं कि हमारे यंग लोग हैं जो हमारे 50% लोग 25 साल से भी छोटे हैं. हम उनको क्या अच्छी तरह से एडुकेट कर सकते हैं? Can we train them well? First of all, I want to ask a question. जब 6 साल के बच्चे 6 साल के होते हैं तब वो स्कूल जाने के लिए तैयार होते हैं. हमारे देश में कितने परसेंटेज बच्चे आज स्कूल जा सकते हैं? कोई बता सकता है? कितने परसेंटेज बच्चे आज स्कूल जाते हैं? लोग बिलीव करते हैं उनकी बातें? हाँ? बात यह है कि 1980 के दशक में शायद 35% बच्चे स्कूल जाते थे. आज पिछले 20 साल में 25 साल में खास करके जो कंटिन्यूअसली इस बारे में आगे हम लोग बढ़े हैं, आज 96% से ज़्यादा बच्चे स्कूल जाते हैं. It has exceeded 96% throughout the country. And it is not a few years of work. It has been a work of last 25 years. उसमें हर तरह की चीज़ें काम की है. मैं उसके ऊपर अधिक नहीं बोलूँगा. हाँ, मैं अपने पर्सनल एक्सपीरियंस पर ज़्यादा बोल सकता हूँ. 1981 I joined IIT Kanpur, IIT Madras as a professor. And one thing that happened is that I used to get a lot of parents bringing their young kids, their young daughter, young son, and they used to sort of say, this person their child want to study engineering. They want to study engineering. They are very bright. See, my daughter is so bright. My son is so bright. How do I get them to study engineering? Can you help them get admitted? The problem at that time was that there were only 100 engineering colleges in the country, only taking 20,000 youngsters every year. Now, only with 20,000, with that time 750, 800 million people, how many could actually get admitted? What about now? Today, all of us know that we have 4,800 engineering colleges, 1.7 million students get admitted. We have seats for engineering every year. Not all of them get filled. Only about 1.5 million get filled. What is even more important is that 25% of the people who actually go to these engineering colleges are from below poverty line. And 25% are from the villages. What does it really mean? It really means that in something we have achieved. We have achieved, number one, quantity. And this is again effort of last 30 years. We have achieved equity. And same thing is true if you take MBA, pharmacy, and various things. What have we not achieved? Well, what have we not achieved is quality. And quality has particularly gone down in this rapid growth and equity drive. But who has to fix it? I don't think it is completely responsibility of someone else, or even I'll say government. The responsibility belongs to us, the teachers, the scientists, the professors. If we cannot fix the quality, who else will? The problem is that it appears to be such a big problem, people sort of say, oh, our quality cannot be fixed. And this is where I sort of say that we have really not made an effort. I don't see any reason why I won't say that we will completely fix it, but we cannot make a significant difference in the next 10 years. For example, some of us took Kakotkar, sir, Mashelkar, myself, several of us all said, well, let us show what is possible. Let us take 500 engineering colleges. And can we make a significant difference there? Because if we can do that, then that will give us some model that how do we go about fixing. Of course, it will vary from area to area. It can go about fixing quality. And there was a committee set up. I was asked to be the chair of the committee called Quality Enhancement in Engineering Education, focused on 500 engineering colleges. And what are we looking at? We actually looked at, well, the students do not have good quality teacher. Most of these, you go beyond the top institutes, IITs and some other institutes, you find that the teachers are not of high quality. So we sort of say, what part can go directly to students? Then similarly, we sort of say, well, teachers are not sufficiently trained. What can we do as far as teachers are concerned? And then what can be done in terms of governance, transparency, rating of these colleges, because these are very integral part to actually fixing the quality. Fortunately, this is where technology can help. Most of us know the information and communication technology is totally today transformative. It is possible, even on mobile phones today, we can actually even watch video. So the question came, can we leverage ICT to fix quality or start fixing quality? I don't think ICT in itself can fix quality. So what we started doing is that we recognize that ICT-based education can play an important role, but also recognize the role that the teacher and educational institute would continue to play. In the West, there is a move that this ICT-based education will replace teachers and colleges. That can never happen, because finally a person is not trained by material. I mean, ICT-based education could be like another form of a book. It's finally the teachers who inspires and changes and make a difference in shaping the quality of the students. So we, however, therefore sort of said that ICT can help in quality of education. It can in fact help the teachers and educational institute rather than replacing it. Especially in countries like India, where fast expansion has taken place and where the teacher quality is not very high. And we, therefore, this January, we started this. We started first in 100 colleges. And what we did is that we went around 4 of the IITs, IIT Kanpur, Bombay, Delhi, and Madras, and sort of said, who are the best teachers there? And how do we figure out who the best teachers are? Well, we actually asked the students. That's the best way.
We looked at the student rating. We looked at the student rating for 3 years and found out that these are the teachers who are known to be the best undergraduate teacher. And we caught hold of 25, 30 of them and sort of say, well, can you now give live classes, live over video, interactive using internet to these 100 colleges?
Live classes, interactive. So there is a teacher who is now, instead of teaching one class of 60 students or 100 students in one place, is actually now teaching 60 into 100 students, 6,000 students with interactivity. Now, we made sure, however, that this role of live classes is not going to replace your regular course. We said that 1/3 of the course will be taught like that. 2/3 will continue to be taught by the local teacher. And the local teacher will also attend these live classes and participate in interaction. It will help the local teacher also grow. It will also help the students. For many of us, I remember that when we were in IIT Kanpur, what happened there was that a top quality teacher, people like Professor C.N.R. Rao, not just taught us material, they inspired us. A high quality teacher inspires students. Teaching subject is one part, but actually inspiring is another part. What we found over the last 4 months when we actually did this, that when these best teachers from IIT were starting to give video live classes to the students all over the country, the students were getting inspired. And the inspiration is all that we really need. After that, all kinds of other materials can actually provide it. So we created this e-content to provide them material. We then started remote tutorials. What we got is that we got some of the young faculty and some of the research scholars to actually take tutorial for 30 students in a college in Bulandshahr. It was being taken from somebody who is sitting in Bombay. And this again can be done using ICT and started making a difference. We have all heard about MOOCs, the massive online courses that we actually did. But we didn't confine it to only the lectures and the tutorials. We went a step further and said, can we really do also the labs? And many, not all labs, but many of the labs, we actually created remote labs where the equipment is sitting at some place and students are connecting to that on internet and actually conducting the experiment. And whole thing was organized that they were trained to do that, and it started making a big difference. What I'm trying to point out, that if we decide to fix things, we can. And since we need to always see that we can't just fix 1 or 2 colleges. We need to fix 100 colleges, 500 colleges, in fact, tens of thousands of colleges. And we need to figure out how to go about doing something like this. So we realized that ICT can certainly enable direct-to-student program which delivers and gets the pedagogy right. The important thing is many things that we tried in the beginning just did not work. We had to try it, figure out what works, what makes the student learn, do not make the student learn, and need to keep on correcting. What we are able to get is that when students were going through the material on their computer, every click that they did, we are actually able to get information about the click and collect it at some particular place and analyze it. And we are able to give individual feedback to each student that how long the student is taking time. Is the student saw the video for the whole time? Did the student answer the question right? And actually start trying to individually focus training. And very early results were seen. In a similar manner, we are focused on how to get some of the best students to become tomorrow's teacher. One thing that we did is that we actually went to these 100 colleges and started doing a quick poll. How many of the teachers there were amongst the top 15% in their class when they were students? And we found practically none. We then tried to find out whether they belonged to 15 to 30%, and we again found that there were practically none. Now, if the top 30% of the students do not become tomorrow's teacher, how are we going to really teach people? So we then started sort of saying, well, we'll pick up the top 15% of the students anywhere, and we'll create a stream for them to become teachers. teachers. We'll help them. Help them and get them to become teachers before Infosys finds them and takes them to do a routine ICT job. And this is the kind of thing that we started trying. All of them are very early, and we, however, are finding that if we decide to do things, we can make a difference. I'm not going to talk more about it. One can get into details about it at some point of time. But if we decide to make a difference, we can make a difference. I'm going to talk about something, and I'm going to spend about 20 minutes talking about this, something that we all can relate much more easily, and where our work has actually already progressed to a very, very significant extent. A very simple idea. Can India's power cuts ever be a thing of the past? We have all lived for last 30 years, 40 years. We have been dreaming, but we are all suffering with the power cuts. First question is, why does power cuts take place? Well, power cuts takes place because there is a certain amount of demand and there is certain amount of supply. And the demand exceeds supply. Very simple. But if you look at the day, you also find that the demand actually peaks during certain hours. And that if the supply is not able to match it, that's the time the power cut takes place. We actually started looking at the power exchange data. Power exchange is like a stock exchange, where all the producers of the power sell power to the power distribution companies, which actually then buy the power and distribute it to us. And we find that every day, at the late in the night time, the power at the rate at which they buy power can be as low as 2 rupees. But every day in the daytime, it increases to 4 rupees 50 paise and 5 rupees. Now, this is the cost of the power at the source of generation. By the time you transmit and distribute, you'll have to probably add another 50%. What we also found that in a bad day, it goes up to 20 rupees. Now, why does it go up to 20 rupees? Because there's a huge shortage and people have to pay as high as 20 rupees. These are distribution companies. And by the time, therefore, they will supply a power to us, their cost will be around 30 rupees or 27, 28 rupees. And if they can supply us at 4 to 5 rupees, they will, of course, lose money. And basically, it is a reflection of the situation that the power demand is much, much higher than the power supply. So as a result, we see in major cities 2 to 4 hours cut. As you go towards villages, power cuts can be 20 hours, and 30% of our Indian homes are not even connected with power. About 20% use diesel generators and battery inverters. That's an upper section of 20%. As soon as I saw a little while earlier, there was a power cut in this at around 11 o'clock, and then after probably a generator came back, and probably, I don't know whether we are still working, the probably generator is now shut down. We heard that noise, but we use generators and we use battery inverters. The remaining 80% just suffer. I'll come back to generators and battery inverters later, but let me therefore focus on what can be done on something like this. After doing a lot of different looking at what can be done, we started going deep into it. And let me point out that some of us who worked on this are actually not power company people. We are not power experts. We are more like telecom experts. So we started getting into this. The question is, why does power cuts take place? When demand exceeds supply, so if you have certain, say, you are a distributor in a particular city, and if the demand exceeds supply, what you will do in certain areas, you cut the power. When you cut the power, the supply, the demand starts falling, and then when the demand is equal to supply, you can actually supply to that. So you are doing a blackout in certain areas. That's what actually is done. Today's grid is designed to either carry full power, or what we call 100% power, normal power, or a blackout, or no power. During full power, you can draw whatever you want. You can connect whatever device, turn on whatever you want. During blackout, of course, you get no power. So the question that we started asking, that why can't we introduce a new scheme of power? Instead of cutting out the power and having a blackout, can we say, we will not cut it to zero, we'll continue to supply 10%, 15%, we'll continue to supply that much power. Is it possible? I call it brownout. Is that possible? The point is our current network is not designed for that. Why? Because as soon as you start supplying that, the consumer will turn whatever the device they want to, and they will start drawing out however much power, and it will exceed the 10-15%, and the power will be cut. And the second, of course, 10% is too small. You wanted to really make a difference, you should have increased that. So we sort of said, well, let me first see how can I supply 10% of power and do a brownout instead of a blackout. A very simple challenge we took up, that can we supply 10% of power? Now whether 10% power is good enough or not, we'll come back and we'll talk about it. But can we supply 10% of power and still it doesn't create a problem? We came up with a simple scheme, sort of say at home, once the power line comes to it, we'll supply power on 2 lines. Like today the inverters do, we'll supply power on 2 lines. One line will be your current line, unlimited power, but it will be cut off during brownout. Whenever there is a shortage, it will be cut off. A second line, on the other hand, is a new line which will have limited power. You can't put any, it can only give you limited power. You can actually have that if you try to draw more power than that, that line goes off. So it can only give you limited power. But that power will be on all the time, during the normal time as well as brownouts time. So this is basically what we did. The incoming line will come. At home, we built a very simple brownout controller. We gave 2 lines. One line was the unlimited power, the existing line. The other was limited but uninterrupted. So very simple concept. Can we give 2 lines? One will never be cut, other will be cut. In that, only so many things that can be used. A simple concept. Now, but how does each home get to know that now we need to operate this brownout control? How does it know now it is brownout or normal? Because if we cannot tell that, things will not work. So and the important thing is everything needs to be transmitted on the existing power grid. We cannot change the power grid. And we need to signal the normal and brownout condition instantly. How instantly? In few milliseconds. If you don't cut off the main power within a few milliseconds, then overall grid will be overloaded and everything will be cut off. And of course, let's for the minute leave the industry out. For industry, we are doing separate kind of work. Let's focus on home. So we came out sort of saying that during brownout, I'll feed a distinctly lower voltage. Suppose I normally feed, and to my home I get 230 volts. Whenever brownout occurs, I will drop the voltage suddenly to 90 volts. Now, the distinctly lower voltage, but at the same frequency, it will come. Now, is that something that we can do? We'll come back to that in a minute. Now, this can happen instantly. As soon as the power drops from 230 volt to 90 volt, my brownout switch will get operated, and only one line will be operated. The other line will get cut off. As soon as the power gets restored, both the lines will come up. So 230 and 90 volts become an absolutely sure shot signal which can be used to transmit power. It can signal to customer the state of normal and back out, and industry, we can use that to cut it out. The question is, also we sort of said we will only supply 10% power. Now 10%, if you want to reduce your demand, if it's, instead of cutting it to 0%, we cut 90%, and supply 10%, still it is okay. In certain areas, I can do a brownout. Other areas, I can have a normal power, and I can balance my load and demand. So the very simple concept will enable us to do that. The next question came, so how will we do this? So at the substation, typically we use a 33 kilovolt line. We have a transformer which is to 11 kilovolt. This line is what actually comes close to our home. And it comes to our home, and there is a distribution transformer which steps it down to the 440 volts and 230 volts and supply us to each home. This is what the normal situation is. This is where the control is done. The blackout control is done. Whenever this distribution line, 11 kV line, is what is cut off whenever in certain areas power has to be cut off. We sort of said we'll replace this. We'll replace this by a concept of brownout. What we'll do is that we'll only take about 10% of the power. We will not take more power. We will do a step-down transformer. It will step it down to lower voltage and supply that. So instead, either we will supply normal power or we will supply the step-down power. And it will go to the distribution transformer, and will go to the home. At industry, it will see a low voltage and it will cut it off. At homes, you will get 230 volts and 90 volts. What will happen when you get 230 volts and 90 volts? But even assuming that we are normally designing for each home 1 kilowatt power, 10% is not enough, not even good enough for one tube light and one fan. So what is this 10% power? I mean, this was the next question that was asked. 10% is too small. Now one could have said, now supply 25%. But if I start supplying 25%, my load can continue to be overall high, and I may not be able to still meet demand and load. So we sort of said, well, instead of supplying this 10% power in the normal way, we came with a second innovation that's uninterrupted, but limited power will be supplied as a DC power. Now, why DC power and how does it really help? Well, it will support only DC appliances. Now, DC appliances, lights, DC fans, television, and electronics. In fact, that's what it will do. My claim is that these are 2 to 2.5 times more energy efficient compared to AC. So the limited 10% power actually go a long way. And it will create a huge pull for DC devices. Let me look at it. Most of us now are starting to move. We use either CFL or some fluorescent light. But if I use a LED, it consumes, typically a fluorescent light consumes 40 watts, 36 watts. If I use a similar LED lighting, it consumes only 15 watts. And the world is moving towards LED lighting. And LED uses DC, whereas fluorescent uses some kind of AC. So if I use DC and supply LED, I don't need as much power, actually need much less power. And I can do all my lighting one by one like this. What about the fan? The next important thing comes fan. A normal fan consumes 70 watts, the fan that we use at our home. But if I make the same fan with brushless DC motor called BLDC motor, it only consumes 32 watts. So from 70 watts, it drops down to 32 watts. It gets more interesting. Sometimes I don't put the fan at the full speed. Suppose I put the fan at speed 1, and I use an AC fan, I still consume about 60 watts. But when I use a BLDC motor, it consumes only 9 watts. So my power consumption goes down not by a factor of 2, but 3, 4, even 5, depending on where I'm operating. So DC makes a lot of sense. And I can use the same DC principle tomorrow to do air cooler, refrigerator, air conditioner, but I'll not talk about it. Electronics. I use television, I use laptops, cell phone, everything. All electronics are DC. Television uses DC, particularly this LED and LCD television. All laptops, everything only uses DC. So what do? We actually take an AC wire and do a AC to DC conversion. Have you thought about how much power we lose? I have this HP laptop, one of the best companies, and I have a converter. It loses about 35% of power. I have a Nokia cell phone charger. It uses more than 50% of the power. If I directly have a DC, then I don't lose all that. And similarly, my television. As also LED or LCD television, it takes AC, converts it to DC, and loses about 30% power. So what I'm pointing out is if I start using DC lights, fans, electronics, then my power consumption goes down a factor of 2.5 or even more. Now, world switched over to AC for transmission of power. Let's not get into it. Time has come to probably switch back, at least at the premises. Once you come to home, it can come as AC, but can I now give DC and give a second line at least as DC? Main line can continue to be AC. So this is what we sort of said, well, we will provide to each home at least 100 watts DC line. So what at home, the 230 volts line will come. It will normally go through a meter and will go to a 230 volt unlimited line. But the minute it sees 90 volt brownout, it detects that and cuts off the AC line. So the AC line is always cut off unless it is normal supply. Brownout is always cut off. But whether I get 230 volt or 90 volt, I can continue to take another unit which converts it to DC, 48 volt DC, 100 watts, meter it and supply it all the time. This becomes uninterrupted power. And what can I do with 100 watts? For example, with 100 watts, well, I can enable 3 lights, 2 fans, and a cell phone. Not too bad. 3 lights, 2 fans, and a cell phone. A small home can certainly doesn't have anything more than that. Or I can shut off 1 fan and I can turn on a television. So I can have 3 lights, 1 fan, 1 TV, and cell phone, which is again not too bad. Most homes will be able to do that. And it can be installed incrementally. On day 1, people may not buy a light and a fan. They may buy 1 light, 1 fan. Then gradually they can keep on moving in that direction. 100 watt also is small enough that even in the worst power situation, I can always find 100 watts to every home. That's the key idea. And in fact, 100 watt is small enough that if I want to expand to the 30% which are not connected, we can actually do that. So every home can get that. But what if I want more? Saying this is fine for a smallest home, but my home is bigger. I have 4 fans, 5 lights, a larger television, maybe a second television. I have a laptop, 2 cell phone, 3 cell phone. Can I get powered all of them? Well, that's the advantage when you do this. So far, I have talked about providing 100 watts. If I want more, all that I will have to do is take a solar panel, put it on my rooftop, directly, solar PV gives me DC power. When I use it today, I convert DC to AC, and I lose about 15 to 20%. If I directly connect it, I don't have to do anything. I can directly connect it. Similarly, if I use battery stores only DC power. So I do AC to DC conversion, store it, then again DC to AC conversion, 30% power gone, probably more. If I directly use DC, it has a huge advantage. And one can move in that direction and then provide this. So suddenly this power that I can get is not 100 watt, I can get 300 watts. I can get even 500 watts. And I can, if need be, I can even add a small amount of battery. And suddenly I can power even a larger home. Using solar in a DC manner makes a huge difference. So let me look at, are we ready for all this? For example, today, from the grid, how much does the power cost us? Well, the power costs us between 4 rupees to 9 rupees. There are some places where it is less than 4 rupees per unit. 4 rupees per unit to 9 rupees per unit. 4 rupees to 9 rupees. 4, 5, 6 is what is charged to home. 7, 8, 9 is charged to the commercial homes, places. But I call it a Ram Bharose power because I don't know when I will get it. I get it, I get it, I don't get it, I don't get it. Now, most of us use diesel generator. We don't even know. You calculate the full cost of a diesel generator. That means the cost of the capital, depreciation, interest rate, because any money today costs us at least 13 to 14%. Take all that into account, and if you run the diesel generator at full load, it costs you 24 rupees per unit. We very often complain about the utilities, but we are willing to pay 24 rupees when we turn the diesel generator on. And if the diesel generator is not running at full capacity, if it's running at half the capacity or 40% capacity, the cost goes to 34 rupees per unit. This is in spite of subsidy that we have in diesel. Then we sort of said, well, diesel may be bad, but I use an inverter. Have you actually ever calculated the cost of an inverter? If you take the total cost of the inverter, the initial cost, depreciation, interest rate, amount of charging, discharging it will do through its lifetime, the cost of charging, which is around 5 rupees, the cost will again come to 17 to 20 rupees per unit. So we often land up, we put in this inverter, we'll land up spending 17 to 20 rupees. We don't even bother. Even Anuradha doesn't protest. She protests on all other expenses, but this is one thing that she doesn't protest. So, on the other hand, if I take solar directly on my rooftop and directly connect it in a DC form, the cost will be less than 5 rupee 50 paise. It will be closer to 5. It can be even 4 rupee 50 paise per unit. Again, I have to take the lifetime, I have to take the depreciation and the interest rate. All this I'll take. Of course, it's only daytime. If I convert to AC, I'll have to add another rupee 50. So it goes up to 650, but still not outrageous like battery and diesel generator. So, and what I'm therefore pointing out, that given this situation, if I have something like that, that 100 watts keep coming from the substation, and I can add whatever I want on the solar, it can actually ensure that most homes can get the lighting, fans, electronics covered. It doesn't, this solution does not cover your heater, your air conditioner, does not cover iron, today does not cover mixer, tomorrow there will be DC mixers, does not cover today refrigerator, but tomorrow DC based refrigerator will also come. So this simple innovation, this is a power systems distribution innovation, where you sort of say, instead of blackout, instead of zero power, you transmit at least 10% of power. It enables home to not suffer blackout. And this can be done in a very cost-effective manner in every home very quickly. At the same time, since one line now is a DC line, you can use it, you can need not use it. If you don't use it, you don't get the advantage. But you can, next light that you buy, next fan that you buy DC light, DC fan. It creates a market for the DC devices, energy efficient devices. We all know that they are all energy efficient. There has been a lot of effort to push them, but push does not work. We are now creating a pull, because people will buy this. And we can make all of them in India. There is none of this technology today. In fact, ever since we started a year back, today 4 companies are actually already making them. This is the way to get manufacturing also focused in India. And make decentralized power attractive. I can directly buy solar and connect it. So it will add. So both on the demand side, it actually adds very significantly because I'm using energy efficient devices. And on supply side, I'm adding solar power. Every home. Now just imagine, and it costs very little. The unit that we talked about in volumes, that unit which separates the two lines will cost only about 1,000 rupees. So it really practically costs nothing. Practically no change to the power distribution network. You of course need to add that transformer. You need to either add the transformer or take a tap from the existing transformer. That cost is practically negligible, 150 to 200 rupees per home. So it's not really significant. That certainly, to give a power which is without interruption, it's a very, very good investment. Strictly speaking, if political process decide to manage subsidy, one can even do that. For example, one can say the lifeline, the DC power, will provide with subsidy. The AC power will be in the market rates. Now, since the DC power will be the lowest income people, you have taken care of lowest income people, and there is no reason to subsidize the other than low income people. So AC power could be market rate. So that will also help the distribution companies come back to life. We actually developed this technology. This is less than, we conceived of this about a year back, April. We actually have been working on it for 6 months. It took us step by step to figure out. We conceived of the solution a year back. We developed the technology, first deployed it in our test bed in the labs. We found it working. Then we actually deployed it in homes and offices at IIT. We commercialized it. Today we have companies which are making BLDC fan, LED lighting, cell phone charger, DC, TV charger, set-top charger, and the UDPM. We actually did that. And today we are doing pilots in 4 states, in Tamil Nadu, Andhra Pradesh, Kerala, and Karnataka with the State Electricity Board. 500 homes in each. We will be able to, we have started installing, and we are hoping that in next few months we'll show it completely working. There are new apartment builders who are coming and sort of saying that I want to get ready and build the whole thing right from the beginning. And we are also working on rural trials. For example, 30% of our homes are not connected. We can actually, in a very cost-effective manner, with solar, even if there is no power or there is a limited power, we can actually provide this because the amount of power reduces. And what we are trying to sort of say that this much power is not bad. At least have this. You have the other AC line. You can always have more. Nobody is saying that get limited to this, but do that. Well, I will pretty much end by saying India can aim big. The decentralized solar that I talked about, where you put a unit at every home, basically means there is no transmission and distribution losses. The transmission and distribution losses for centralized plant is as much as 30%. Some places even higher. We save on that. That's a byproduct. And 100 million homes, very easily with something like this could actually add 1 kilowatt each. 1 kilowatt will cost around 50,000 rupees. 50,000 rupees one-time investment. For the next 20 years, you will get the benefit of that. If 100 million homes install it, we get 100 gigawatts of power, peak power. 100 gigawatts of peak power today is 40% of the current peak capacity. Today, for total capacity that we have is around 240 gigawatt. In practically no time, we can add 100 gigawatt. At the same time, we introduce whole focus on energy efficient. I'm not even talked about what we can do at offices, complexes, industry, agriculture. Each sector we have done enough work. Today I just thought that we will actually focus on that. What I'm trying to sort of say, that we today dream, we are absolutely confident that by 2030, 50% of India's power will come from solar. 50% of not today's power. Today is 225. We are hoping that by that time we may consume about 700, 800 gigawatt. We can get 400 gigawatt from solar. There is no reason why we cannot do that. And decentralized will play a major role. I'm not saying decentralized will be the total one, but I think we can get about 200 gigawatt from decentralized and 200 gigawatt from centralized. And this is something people will themselves spend. Just like we buy our own stuff today to make things work. And this is something that can transform India. This, we can be leaders in the world if we do this. And this is not an empty vision. We also know what are the kind of technology that we need to work on. I was talking to Vijay that the only technology that is missing in this, where it will help us gain, is battery technology. Can we become the leaders in battery technology? And that brings me to the next dream. Other problem in India is that we don't have oil. Whatever we try, we don't have oil. We have to import oil and gas. We can get a little more. We can exploit shale gas, but we'll never be able to get more than 20-25%. India just does not. Indian geography does not have it. So are we going to be forever dependent on somebody? And remember that when we are going to depend on somebody, we can also be blackmailed. Our weakness comes from being dependence. If you want to be a strong nation, we sort of say, well, can we not think of moving to electric vehicle? Assuming that 50% of electricity is anyway being generated from solar, can we say by 2030, 50% of our vehicles be electric vehicle? People will say this is ridiculous, very high aim. I hope, or I don't know, but I hope I will live till 2030, and I hope to see that. Why? Because there is nothing in the technology that is not ready today. Technology is ready today. Today we can start in India to start building cars, which are, and scooters and mopeds and larger vehicles, which are not petrol and diesel based, but electric vehicle. And price will be on par. That's an interesting thing. It is no reason that the price is higher. If you take two parts into account, one part is the price of the vehicle, another is the price of the fuel. Fuel is battery plus the charging. You have to take the battery in the fuel. Just like today, petrol is a fuel or diesel is a fuel. Battery plus charging is a fuel. If you separate the two, if you add battery to the cost of the car, then of course it will be higher. So price is on par. And over time, these batteries are only going to improve. All the electronics cost is only going to go down. We are actually building electronic car. So it's a matter of few years where we'll start getting huge advantage, not just being on par. Today we are on par, tomorrow we'll have an advantage. If we take a lead today, if we put together, I told Vijay that we should set up a special group in Department of Science and Technology, which will lead, which will be academia, industry, and together, and scientists working to sort of make this possible. This is not, again, an empty dream. This is something that we can certainly attain. And if we actually don't do it, it is our failure. Well, I want to end this by sort of saying, one can talk about what can be done for public health center, agricultural growth, small farmers. Can we prevent water wars? Water is extremely important. Recently, Prime Minister's Scientific Advisory Committee has come up with a report. It's worth reading, but one can talk about more what can actually be done. Can governments be transparent? And can ICT be used as a prime interface to government? I shouldn't have to ever go to a government office. That's something that is possible. All this is doable. They don't take 30 years, 50 years. They are all doable in 5 years you can show significant improvement. In 10 years, you have got there. That is what our aim should be. And if you do that, what I'm pointing out, that technology combined with innovation can go a long way. We need to, of course, think of big problem and not be afraid of that and get full-fledged. And sometimes it may take us a few years. Just immerse yourself and find a solution. Understand what has been achieved. It is very important to understand. Sometimes we beat down, oh, nothing has been achieved. We will never achieve anything. Because, yes, there has been always something there. We will have to ride on top of it and achieve more. And what needs to be done, and get that. Maybe a small thing has been achieved. Doesn't matter. We'll get the big leap. If large has been achieved, we'll make the difference. Do not get too attached to your solution. This is another thing that I will tell from my experience. Because any technology that I will come with, tomorrow somebody will come with a better technology. And be open to that. Very often we as a scientist fail to. We then start sort of saying, for example, yes, UDPM can solve the problem today, we should do that. But it's not that as if that is the end of it. Tomorrow somebody will come with better one. And we can take that up. Do not call quits when difficulty arises. That's another thing. There will be difficulties. At times you will feel defeated. No answer. Do not call quits. If you follow these two, and remember that one can always improve on the solution. If you can get there, I think it is possible for us to solve big problems. This is what science and technology establishment in the country should push for, and this is something today the scientists and technologists and our youngsters are capable of delivering. We just have to decide to do it. Thank you very much.